All right, we're going to journey all the way back to the dawn of the universe. Why? Because we're on the hunt for one of the most terrifying and, let's be honest, fascinating objects ever theorized. We're talking about a star with a very, very dark secret hiding right at its core.
Yeah, just let that sink in for a second. A star, the ultimate symbol of light and creation, is literally being eaten alive by a black hole that's living inside of it. It sounds totally impossible, right? Like something straight out of a sci-fi horror movie.
And that is the central, mind-bending paradox of what scientists have dubbed a quasistar. If you were to look at it from the outside, you wouldn't suspect a thing. It would just be this brilliantly shining star, maybe thousands of times brighter than our own sun. But the very thing powering it is also what's trying to destroy it.
That's right, that's the huge mystery here. How on earth can a cosmic monster like this even exist? And maybe, more importantly, what does it have to do with the universe we see around us today? Well, the answer is a story all about an impossible, delicate balance. Okay, so this isn't just some crazy thought experiment. No, the quasistar might actually be the missing piece to a very real puzzle, a cosmic mystery that astronomers are trying to solve right now.
See, this theoretical monster, well, it might be directly connected to actual data we're getting back from space, the James Webb Space Telescope. It's been spotting these things called little red dots, and these are incredibly early galaxies that are giving astronomers a massive headache.
So here's the deal. The problem is these galaxies are just way too big, way too early on in the universe's history. According to all our standard models, there's just no way there was enough time after the Big Bang for them, and especially for their central black holes, to get that massive. It basically breaks the rules of cosmology as we know them.
So this leads to a pretty wild idea. What if these supermassive black holes didn't have to start small and grow slowly over billions of years? What if they got a huge head start? And that is the quasar star hypothesis. It's basically a cosmic shortcut to creating the massive black holes you'd need to anchor those huge early galaxies. So to really get how this works, we need to rewind the clock. We're talking way back to the chaotic, violent early days of the cosmos, a time when the rules for making stars and black holes were, well, they were just completely different. Okay, so in the universe today, the process is pretty standard, right? A massive star lives its life, goes supernova, and then the leftover core might collapse into a black hole. But back in the early universe, the conditions were just insane. You had these gargantuan clouds of primordial gas that were so incredibly dense they could actually skip the whole being a star phase and collapse directly into a black hole seed.
And this direct collapse model, it creates something completely bizarre. Some scientists even call it a zombie structure. And you can see why. You've got this massive bloated shell of hydrogen gas. But where its fusion-powered core should be? Nope. Instead, there's a ravenous, growing black hole just sitting right in the middle.
Which brings us right back to that big question, doesn't it? How does this zombie star not just get instantly devoured? Well, the answer is a really delicate and incredibly violent balancing act.
I mean, it's the first thing you think of, right? A black hole's gravity is supposed to be inescapable, so it feels like this whole thing should just be gone in the blink of an eye. But it's not. And that's thanks to a really fundamental force in physics.
That force is something called radiation pressure. See, as the black hole is just gobbling up all the gas falling into it, that process is super messy and incredibly violent. It releases a colossal amount of energy, we're talking light and radiation, that just blasts outwards from the center.
And that is the key. That's the core mechanic right there. The black hole's own feeding frenzy creates the very force that pushes its next meal away. It becomes this bizarre, self-regulating system. You can think of it like a cosmic tug-of-war between gravity pulling in and light pushing out.
So, picture this. On one side, you've got the relentless, crushing inward pull of the black hole's gravity, just trying to devour everything. But on the other side, you have this furious outward push from all the radiation being blasted out by that very same feeding frenzy. And for a little while, these two forces find a perfect, seemingly impossible balance. And when we talk about the scale of these things, it's just absolutely mind-boggling. They would completely dwarf anything we see floating around in the modern universe. So, for starters, they were just unbelievably bright. All that energy pouring out from that internal tug-of-war made them nearly 3,000 times brighter than our own sun. Just think about that. And as for sheer size,
A quasistar was so bloated, so incredibly massive, that it could have swallowed our entire solar system whole. I mean, everything. The Sun, Earth, all the way out past Neptune. Gone.
But, a tug-of-war like this, it can't last forever. A quasar star is fundamentally living on borrowed time. Its very existence is its own death sentence. That's because while that outer shell is being held in this delicate balance, the monster at its heart is just constantly growing. It's getting heavier, more powerful, with every single bit of gas it manages to swallow. And then eventually, you reach the tipping point. The black hole just becomes too massive. Its gravitational pull finally completely overwhelms that outward push of radiation. The tug-of-war is over. And the star's remaining layers, they just collapse inward and are consumed entirely.
But what's left behind, that's the whole point. You're left with an intermediate supermassive black hole, one that was born in just a few million years. And this is the seed that could perfectly explain those little red dots. It's a massive gravitational anchor, ready and waiting to start gathering up gas and stars to form those giant early galaxies that the Webb telescope is showing us.
It's kind of a grim thought, isn't it? But also strangely beautiful. The idea that when we look back into the deepest, earliest history of space, some of the brightest and most incredible lights we could ever see, they weren't signs of creation. They were actually the death cries of a star being eaten alive from the inside out.
And it just leaves you wondering, doesn't it? If something as wild as a quasistar could exist in that chaotic dawn, what other impossible, terrifying cosmic monsters are still out there hiding in the darkness at the very edge of time?